Okay, so yesterday we looked at the concept of bits and bytes, which is how we store data on a computer. So we looked at a bit, which is the smallest unit of computer memory. So remember, bits were like the zeros and ones. So everything in the computer world comes down to just a whole lot of zeros and ones. So that's what a bit was, and it's represented by lowercase b on each. A byte is represented by an uppercase B, and it's made up of 8 bits. You need 8 bits to store one character, like a letter F, or an exclamation mark, or a comma. Every character is stored with 8 bits. Now, converting between kilobits, megabits, gigabits, terabits was really easy. That's the same as we always do for metric conversions, just like converting kilometres to metres or kilograms to grams. There's no difference in those conversions for bits. The difficulty came with bytes. Now, bytes do not convert according to the metric unit because it's a binary system. Instead, everything works on powers of 2. 2 to the power of 10 was the key number, and that worked out to be 1024. Now, luckily, you do not need to memorise this. This information, including the fact that 1 byte is 8 bits, is given to you on your formula sheet. You do not have to memorise this. It is assumed, though, that you can memorise this, because that's just the normal. You right?
But it's
okay.
on the formula sheet, the other one?
This one is on the formula sheet. Everything for bytes is on the formula sheet, but bits is not. Okay? So let's look at 2 little examples. The first one, I want to do 3 megabytes, remember capital B is bytes, to kilobits. So if I'm going from megabytes to kilobits, first of all, I have to go to just plain bytes and then convert across. So I'm starting at, oops, wrong way. I'm starting at megabytes, so I'm starting here. I need to go up to what a byte is, and then I'm going to convert down this one. So from megabytes to kilobytes, then to bytes, is 2 jumps. Each of those jumps is 1024. They're smaller, so there's more of them, so we're going to multiply by 1024 twice, which means to the power of 2. Well done, excellent remembering. So I've got 30 times 1024 to the power of 2. That will convert from megabytes to bytes. Alright, now I want to go from bytes to bits. So if I have 1 byte, it is 8 bits. So I would times by 8. Is everyone with me so far? So I've gone from megabytes, that should have been a capital. Pretend that's the capital M, I've just noticed that. That's really bad. Because that would be meters, which doesn't make sense. So I've converted from megabytes to kilobytes to bytes. I've then converted to bits. Now I want to go from bits to kilobits. I keep pressing the wrong arrow. Bits to kilobits. Shh. Guys. Bits to kilobits, there is 1,000 kilobits in a byte. Okay, they're bigger. So there's less of them, so I'm going to divide by 1,000. Does that make sense? So all I do now is I pick up my calculator, I type in that yucky, and get some horrible answer. 30 times 1024 squared times 8 to make it bits, divide by 1,000 to make it into kilobits, and I get a really big number. 251,658, let's just round to the nearest whole number, kilobits. Okay? Does everyone understand that one, what we did? Yeah. Okay. Second example, how many 800 kilobyte photos would fit on a 4 gigabyte USB? So if I'm going to compare this and this, they need to be in the same unit. Okay?
Are they the right units?
What's that?
Isn't that kilobytes and gigabytes?
I want to make them the same. it doesn't matter which one I make them. I can make them both kilobytes, I can make them both gigabytes, I could make them both megabytes, as long as they're the same to be able to compare them. Okay? For this question, Kyle, shh, don't talk, focus. For this question, I'm going to choose to convert my gigabytes into kilobytes. Okay, so that they're both measuring in kilobytes. So I'm going to take my 4 gigabytes. What do I have to do to convert it to kilobytes? How many jumps is it from gigabytes to kilobytes? 2. And what do I times by for bytes?
Isn't bytes that side?
I'm pointing to the wrong side.
Wait, for bytes or bits?
It's bytes, not bits.
2 to the
power of 10.
2 to the power of 10 or 1024? Shh. Go.
4196.
Okay, so we've got it times by 1024 twice, which means the power of 2, which will give you a really big number. Okay? So that's how many kilobytes I have. I want to know how many photos are going to fit on my USB. Each photo, we're saying roughly, obviously they're different depending on the detail of the photo, but we're saying each photo is 800 kilobytes. So to know how many fit on this USB, I'm simply going to take this and divide to see how many 800s would fit on my USB. Okay, so on my USB, I would fit 5,242.88 files, or 88 photos. Obviously, we can't really fit 0.8 of a file, that's useless. So we would fit 5,242 photos. Okay, on my USB stick. Does that make sense? Okay, I'm going to give you about 10 minutes to try a few examples of your own.